Hi everyone. Today I want to talk about DMS and radians. So first, what is DMS? Well, DMS stands for degrees, minutes, and seconds. It's kind of like a unit of measure that helps us convert from things that are decimal degrees to things that are a little bit smaller. In terms of units, well, think about latitude and longitude on a globe. DMS, degrees, minutes, and seconds, helps us measure where you are on the planet. It's also a way for us to use dimensional analysis, fancy word for unit conversion, to go from something that we understand to something that we might not understand so much. Let's try some examples. But first, a table. Wow, I didn't think that table was there at that point. How weird. Degrees, minutes, and seconds is broken down to the following components, and we have to think about revolutions, because in pre-calculus, circles are really important. In terms of degrees, we know that one time around a circle from its starting point back to its end point, or in other words, from our initial side to our terminal side, 360 degrees represents one revolution. Now, breaking that down even further, in terms of minutes, 1 degree is 60 minutes. So this is where the minutes come into the degrees. Now, when we break it down to seconds, one level lower or one smaller unit of measure, 1 minute is 60 seconds, obviously. And that means 1 degree, which was 60 minutes, that 1 degree also represents 3,600 seconds. You can try it out and impress your friends with that cool information about seconds and minutes, which you should know already. Moving on. Now we want to convert these things. There are 2 ways to conversions, and that's why DMS and radians are put together really nicely in this video. They both own conversion rates from one to the other. Take a look at example 1. We're going to convert 241 degrees, 9 minutes, and 12 seconds to decimal degrees. Meaning we're going to take that one clunky looking thing and move it into one overall degree measurement. Now let's think about this from a logistical standpoint. 241 degrees around a circle or an angle is a pretty big angle. Now, the 9 minutes and 12 seconds part, well, if there are 60 minutes in one revolution, 9 minutes is a very small portion of that. It's a very small fraction of that. And 12 seconds is an even smaller fraction of that, or part of it. So when we have 241 degrees, our decimal point, or the extra part after that, is going to be relatively small, and it's definitely not going to bring us up to 242 degrees. Let's see how this works. The first conversion is not really much of a conversion. The 241 degrees is going to be my value to the left-hand side of the decimal point. Now, what I have to do next is I'm going to do some addition in terms of the fractional pieces of the minutes and the seconds. 9 over 60, because 9 minutes over the total of 60, which is what our handy little table that's blocking my view is telling us. I'm going to add that to the 12 that we had in the seconds column, or the seconds place. But remember the conversion from the table, that very obtrusive table that blocked my view again. We're going to put that over 3,600. Now here's where it gets kind of a little tricky. I'm going to have to use a calculator to find the decimal values of both of those things and put them together. So let's go ahead and do that on our trusty calculator. The 9 divided by 60 is going to give me 0.15. So let's have 241.15, and let's put the 12 over 3,600 together. Dividing that gives me 0.003 repeating. Well, that's interesting, because the 0.00 just happens to coincide with the 0.15. So I don't have to write the 0.00 because we have it here. Let's break it down a little bit differently. 241 we knew. 0.15 was the 9 over 60, and I wonder if you heard that. That's Titan downstairs, barking for I don't know why. 0.033 represents my 12 over 3,600. So let's do some arrows to kind of get where we're going here. Now this just happens to coincide very nicely where we have 241.15, and the 0.15 would have been in these 2 0 places, and 0.33 or 0.0033. My final answer, or the conversion rate, is going to be 241.1533 degrees. Now, again, let's think about this logistically. 241 is a solid whole number. The 9 over 60 and the 12 over 3600 isn't big enough by any stretch of the imagination to push this ones place to 2. So we're going to have a very low decimal, or a very small decimal, comparatively speaking. Let's think of it one more way and we'll move on. If this was 30 over 60, I better have a 0.5 there, because that would be half of the 60. Moving on. I think this concept's pretty simple comparative to what we're going to be doing and what we have done in the past. Try number 2 on your own. Go ahead and pause me, and we'll be right back with the answer. Okay, so if you got 16.81, you're looking good. You probably would have had also 16.806 or something like that, and we would have rounded up. Now, if you had something with a couple of more decimal places, I wasn't really clear on how many decimal places I wanted, so thanks. 16.81 rounded to the 100th place is what we're looking for. Let's move on to the other way. To go from DMS for degrees, well, let's just go from straight degrees back to DMS. Here, in example 3, I want to convert, again, decimal value to DMS form. So how do we do that? Let's try it. Okay, so kind of like the other way around, we're just reversing the process. Remember that the number that's in front of the decimal place is going to stay valid no matter what. So I'm going to have a 72 as part of my answer regardless of what happens. Now here's where it gets a little tricky. I'm going to take the entire decimal as it is, 0.358. And I'm going to multiply that value by a fraction, not so much a fraction, but I'm going to represent it as a fraction so we can understand the way we dimensional analyze it, which is not actually a phrase. I just made it up. You're welcome. It's going to be multiplied by 60 over 1, and that's 60 minutes over 1. What we need to do here is we need to get the entire decimal as it stands and multiply it by minutes so we can get another value that has a decimal place in it. When I multiply 0.358 times 60, I'm going to get 21.48. Now, we're going to use a lot of that piece of information. The 21 is going to be my value that goes right after the decimal place. So I'm going to have now 72.21. The 0.48, though, we're going to plug into this process one more time and use that as the entire decimal to multiply by 60 yet again. So we're going to do 0.48 times that 60 minutes over 1. Now, think about it like this. 60 times 60 is 3600, which represents the amount of seconds that are in 1 degree of our revolution. So I have to obviously multiply by 60 twice in a row in order to get to that 3600 to represent the seconds place of our DMS. So 0.48 times 60 is going to give me 28.8. Now, typically what we do is we either round it to 4 decimal places or 2. Case in point from our first example, which was 4 units, and then for our second example, which was 2. Now in this particular case, I've already got 2 decimal places, the 0.21. I really don't want to go to a 5th place value of an 8. So I'm going to cut that 8 off, and I'm going to put 28 there. Our final answer is going to be 72 degrees, 21 minutes, and 28 seconds. Voila. Okay, let's get to the second part of the video, radians. Our coordinate plane with a couple of angles, a couple of rays. As in the last video, let's kind of revisit some things. Initial side, terminal side. Definitely an acute angle. We don't have to worry about any of that other pre-calculus stuff right now though, because radians is a major concept in mathematics and higher levels. So what exactly is a radian? If you're thinking to yourself, it kind of sounds like radius, that's a good start. A radian is a measurement when an arc is subtended. Hey, I told you not to use the word subtended, huh? Yeah, I don't want to use that word. That word is terrible. Subtended by 2 radius or radii of a circle is the same measurement as the radius. See, it doesn't make any sense. See, last time I leave you with putting stuff on here, huh? The dog, he's got nothing to do all day. So he does this. It's fine. Subtended is a terrible word. I wish it was never made up. It basically just means intercepted, or things that connect. Here's what this means. And here's what this awful definition means. Never letting you do this again, bro. I have a circle here, obviously. We can classify this as the unit circle, but we're not there yet. Let's say that the measurement from the center of the circle to its endpoint is r, which it is. Let's just not put a number to it right now. We'll label that as r, which is a radius. Now, if you're familiar with circles and you're familiar with radius and radii in general, you know this circle has infinite amounts of radii. It has infinite radius in terms of how many there are that exist. This other terminal endpoint is another radius. Obviously, I don't care about the part of the ray that goes past the circle. I'm only concerned with where it touches the circle. Okay, so we have two measurements that are r, which means they're the same exact measurement. A radian is when the arc that's intercepted between the two measurements of the radii is also the same exact measurement of the radius. So now let's plug a couple numbers in here so we can really kind of identify this. Let's say this r is 5. That means this r is 5, and so is that. This represents 1 radian, when the radius is the same exact measurement as the arc it intercepts. We would classify this as 1 radian. There is never anything about units in terms of radians, because a radian is just a radian. Now, 1 radian, we could get into the breakdown of the degrees, which we'll do later. But 1 radian is about 57 and blah, 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 blah degrees. Not quite 60, but a little over 57. When we talk about circles, something that is extremely constant with a circle is pi. Radians and pi are like a match made in heaven. They're amazing together. Let's see what I mean. Now, talking about pi, 1 circle is 1 revolution around, and it's 360 degrees. Well, 1 revolution around a circle is 2 pi radians. We'll get into the formulas a little bit later. Just take me for my word right now. Now, 2 pi radians is 360 degrees. Just like DMS and degrees, we can use conversion rates to go from radians to degrees fairly easily. So let's try a couple of examples together. The conversion formulas are here. Degrees to radians means this. I take the degree measurement of what I want, whatever it is represented in degrees, I multiply that number by pi over 180. That will change my degrees to radians, and vice versa. If I give you radians, I can multiply that radian amount by 180 over pi. It's going to cancel the pi's out, and I'm going to be left with just the degree measurements. So let's try a few examples together. Number 1, I want to convert 60 degrees to radians. Okay, let's use our trusty formula here. Because I'm starting with degrees, I'm going to multiply 60 times pi over 180. Now, like I said before, pi and radians go hand in hand. Whenever we talk about radians, we're talking about pi. Now, here's what's a little tricky about that. Pi is actually an exact number in terms of it being just pi. Don't think of it as 3.14 blah, 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 blah. Think of it as just pi. So when we talk about radians and we talk about circles, pi is what we like to call an exact measurement. When we talk about converting into degrees, we're going to get into some things that are not exactly pi, and they're going to be rounded. Huh? Let's stick to the facts. 60 times pi over 180 is going to give me 60 pi over 180. We have to simplify this, obviously. And 60 can go into 180 3 times, so we have 1 pi over 3, or just pi over 3. So 60 degrees is pi over 3 radians. Let's see another example. Let's convert 3 pi over 4 radians to degrees. Go ahead and give it a shot. There's the formula. We're just going to multiply 3 pi over 4 times the fraction 180 over pi. Now remember, we're trying to get to degrees, and degrees don't ever have pi in it, so you should not have pi in your answer. Let's come back in a second. Okay, if you got 135 degrees, you're looking good. Now, we could do cross multiplication. I could have multiplied these numbers out the whole way. It might be a little bit easier to kind of cross cancel, or however you learned it in elementary or middle school. The pi's simply go away because we have something in the numerator and denominator. That always cancels out. Instead of multiplying 3 times 180, I'm just going to simplify 180 over 4, and that's 45. You're going to get to know these numbers really quick. 45 times 3 gives me the 135 I'm looking for. Moving on. Okay, let's finalize the video. A couple of things to remember about DMS and radians. Number 1, converting DMS to decimal degrees and vice versa. There's formulas to help us with that. Make sure that you understand our minutes will always be over 60, clearly in terms of a revolution of a circle. That's what we're looking for. And the seconds part will always be over 3600, 3600. As long as you remember those formulas, you're looking good. Number 2, radians are exact measurements in terms of pi. When we talk about rounded measurements, that's when things get a little messy. pi is an exact measurement, and that will help us moving forward for the unit circle. We'll get there. Number 3, we can always use conversion rates to get from degrees to radians and vice versa. So again, the heart of this video is we have conversion rates to go from one to the other. See you next time.